Hello everyone and welcome to Learn with Karma and I Karma, and today we are starting the most important chapter of class 11 physics, and the chapter name is vector and motion in 2D and motion in 2D. So this is my first whiteboard lecture video in my YouTube channel, and so please guys like, share and subscribe, and sorry for bad quality and mic. I will upgrade soon. And first of all, we are doing vectors and motion in 2D, but in this part 1 we are only doing vectors. We are not doing this motion in 2D. So we'll start vectors, okay? And first of all, there are two types of vector. So what is that? Number one is scalar and vector. Okay, so let's understand what is scalar and what is vector. So number one, there are two types of vectors: scalar and vector. Scalar and vector. As you know, there is two types of vectors. Number one is scalar and number two is vector. So what is scalar vectors? So let's see what is scalar and difference between vector. Okay, so there's two vector, no, they have a value. Okay, they have a value, and what is that value? The value is magnitude. They both have the magnitude. Okay, they both have magnitude. And so let's understand scalar first, okay? Then after we'll do vector. So I'll drop this. Okay, wait. So we'll understand scalar. Okay, so what is scalar? Scalar means that when a physical quantity is derived by a simple number, we call it scalar quantity. For example, work, distance or speed. Because in simple words, scalar has only magnitude. In simple words, scalar has only magnitude. So scalar has only magnitude. No. So we'll take one example. Suppose speed. We all know that speed has no direction. We know that speed has no direction. So we got to know this. Scalar quantity has only magnitude, so it is scalar quantity. Okay, so please note the definition. I am reading again. Okay, when a physical quantity, okay, I will write in bold. So here is the definition. Please copy this. This is a very important definition of scalar. So as we know that when a physical quantity is derived by a simple number, we call it a scalar quantity. So as you know, I took this example earlier, but we know that work is also a scalar quantity because work has no direction, and distance is also a scalar quantity. We travel. We have a destination, but when we walk somewhere, we don't know the direction. No, that's why there is no direction in distance. Okay. So next we are doing vectors. Okay, let me rub this. So next topic is vector. Next point is vector. So what do you mean by vector? What do you mean by vector? So the vector is that I will give the definition and I will explain what is vector. Okay, first note the definition. Okay, I'm writing in board. So here is the definition of vectors. And what do you mean by vector? Let's read the definition. Okay, in contrast, a vector has both magnitude and a direction in space. Okay, so now we know that scalar has only magnitude. So in vector we need, if a quantity have to be a vector, we need magnitude plus direction. I'm writing DIRECT. Okay, you all got it, I know. You all will got it, I know. And if a quantity has to be vector, it should have this two qualities. Number one is magnitude. It should have its magnitude and it should have its direction. I know some of you are confused about what is magnitude, no? And the meaning of magnitude is how much or how big, you know. The meaning of magnitude, I will write over here, okay? How much and how big. The meaning of magnitude is how much or how big. As I know you all understand this, and so okay, got it. What is magnitude? And direction, you all know what is direction, no? I don't have to explain. And okay, we know that vector have, if a quantity have to be a vector, it has to be this both qualities, no? So number one quality is magnitude and number two quality is direction. So for example, we have took here the force, no? Force. So for example, there is 5 northeast. There is 5 east. This is not north, this Newton. 5 Newton in east. Got it? There is force, and force is 5 Newton in east. You all know that here is magnitude 5 and here is east. What is east? East is a direction, no? East is a direction. So there is direction also and there is magnitude also. So this is the first example of a vector quantity. VQ. I have wrote VQ, okay? Vector quantity. And second example is velocity. So what do you mean by velocity? I know you all know what is velocity. So there is 5 meters second west. So please tell me what is its magnitude and what it is direction. So this is magnitude 5 meters second and this is direction, and west 5 meters second west. So there is magnitude also and there is direction also. Direction is west, magnitude is 5 meters second. So this is also a vector quantity. We consider this is also vector quantity because there is both magnitude and direction. So let's move on. Example 3. We all know the displacement. So number 3 example of a vector is displacement. So what is displacement? You all know do you all know what is displacement? No. So I will not talk about that topic. So let's move on directly to the example. And you all know this is the magnitude and this is the direction. This is the direction. So a vector should have two qualities. Number one is magnitude plus direction. So it is a vector. So this is the example 3. So now we are moving forward, and so now I will do representation of a vector. So now we'll do representation of a vector. Okay, we'll do representation of a vector. So as we know, vector has a magnitude and a direction. Okay, let's begin with the simple arrow. So this is L and this is a head of an arrow, no? So we'll consider this head of the arrow is so we know the head of the arrow is heading somewhere, no? So it's heading towards here. So this is the direction. So we know this is the direction. So what do you mean by L? L is magnitude. So we'll denote from today, we'll denote this sign as a vector from today. Okay, we'll write vector like this. If we write A and this A is vector, no, so you have to write like this, and this is a vector. Got it? And this is a vector. And now and there is magnitude, there is a magnitude also, and there is a direction also. So this is a vector. And now for example we'll take, and now for example we'll take, and now for example we'll take okay, force is equals to 100 Newton. Force is equals to 100 Newton, no? So we all know we'll write vector, we'll write this type, we'll write this way. Okay, the vector from today. So F is a vector quantity, so F vector is equals to 100 this, because the value of this is not this, no? And now so as we know, there is a magnitude and there is a direction, m plus d, so this is a vector. So vector, I know all of you are cleared with this vector, no? So we'll take a small example. Okay, let's differentiate between vector and magnitude. Okay, so let me wipe this. So now we'll understand notations of vector and scalar. Okay, so as we know, a there is no direction sign, no, there is no direction sign, so this is a magnitude. So this is a, because there is no direction given in this point also, no, so this is a magnitude. And please pause the video, and what is this, please do, and please comment also what is this number 2. I'll not do, because you all have learned in class 10, no? So okay, I will explain. So this is a mod, and in physics we consider a mod as a magnitude. In physics we considered a mode as a magnitude, and there is only magnitude, there is no direction given at this certain point. So, and number 3, there is a and there is direction also, that we have done lastly, no? And there is direction also, so this is called a vector, and there is magnitude, and there is what, direction also. 4 units south, there is direction and there is magnitude, so this is a vector. And example number 4, this is the notations, okay? And sometimes in some books or in some exams, this type of sign is also come. This is a, what to say, dark A, no? This is a dark A, so this is also considered as vector, okay? Because there is direction also, and there is direction also, this magnitude, not direction, and there is magnitude also, so this also vector. And for a small example, we'll take B is equals to 4, and what is this? This is a magnitude, and B mod is equals to 4, and this also a magnitude. Got it? And for example of vector, we considered this. This is known as tail of a vector. This is important. Note it this all. And this is considered as the tail of the vector, and this is considered as the head of a vector. Got it? Oh, I'm sorry, my camera angle was not correct. So my camera angle is correct. Please see here. I will explain again. I'm so sorry for that. This is the tail of the vector, and this is the. So let us consider. I'll do it again here. This arrow is a vector, okay? And so this is a tail of a vector, and this is a head of a vector. Got it? So that much for this, and so we are moving forward, and now the main topic is the types of vector. We are doing the types of vector. So we'll do the types of vector in second part, so please stick with me guys, and please like, share and subscribe. Okay guys, this is my first video, and thank you so much all.